All right, everyone. Good morning. Today, our goal is we can solve a quadratic by factoring. And so, a couple things we're going to need, and I went ahead and copied and pasted them here, is in order to solve, what does that mean? Solving means what are the x-intercepts? And so, probably easier. There's two different ways to solve. There's actually 3, 4, 5 different ways to solve. We have solving by square root, solving by quadratic formula. But I would say probably the easiest method is to solve by graphing. Now, what does that mean? It really does mean you just type into Desmos. Now, technically, you could type this in to Desmos and it knows what to do. Pretty sure. Like I could type this in 4 minus 3x. And so what does that mean? That means what are the x-intercepts? Negative 0.8 and 0.5. Those are my x-intercepts. Now, if you use something like this, you need to solve for y, or not solve for y, but put in standard form. And what does it mean to put in standard form? What that means is, let's see, you move things over. So you would move this over to the other side. That makes it a plus 3x. Move this to the other side. That makes that a minus 4. So you get 10x squared. And apologize for my sloppy handwriting. You move that over, or you can think of it as adding 3x to both sides. I like to just think of it, if you move it to the other side, it changes sign. So I got plus 3x. And then I'm minus 4 from both sides. That becomes minus 4. So notice, if I were to type that in, 10x squared plus 3x minus 4. Oh. They're not the same thing. Interesting. They look different. So I guess just to be consistent, I don't know why they're not the same. Okay. So yeah, we probably should put this in standard form on Desmos before we use it. So what does it mean to be a solution? The solution is, where does it cross the x-axis? Parabolas usually have 2 solutions. If you ever look at the fundamental term of algebra, it says it always has 2 solutions. They could be the same solution twice, 2 distinct solutions, or 2 imaginary solutions. So all I need to put down is negative 0.8 and 0.5. So I'd go over here and I'd say, okay, my solutions are x equals negative 0.8. And then we like to use the word or, x equals 0.5. And again, I got that from here and from here. You may also see it written like this as a coordinate, negative 0.8, comma 0, and 0.5, comma 0. All of those are the same thing. Okay, so solving by graphing isn't that bad. You literally, you just put it in standard form. Like I'd move the 6 over, I would move both of these over, I'd move the 2 over. Here I'd want to move the 5 and the x over here. You put it in standard form, you can use Desmos, see where they cross the x axis. If you have one of these, it has quite a few more steps, but this is what you're allowed to use on the ECT. All right, so now I'm going to teach you how to solve by factoring. Solving by factoring So we're going to solve by factoring. Make that a little larger. Solve by factoring. So first thing I would highly encourage you to do is put all of them in standard form. This one is in standard form already. We got the x squared term, the x term, the constant equals 0. And remember, standard form is right here on the top. It says ax squared plus bx plus c. Here we have ax squared, but x and 4 on the wrong side. So I'm going to move the x over. So I already had 3x squared over here. I forgot that I don't have much space on here. So I'm going to need to zoom in a little bit. Try again. So when I move the x over, I already had 3x squared over here. When I move the x over, it becomes a minus x. And then when I move the 4 over to the other side, it becomes a negative 4. And because you have nothing left over here, you set it equal to 0. So now it's in standard form. You may be thinking, why didn't you just move this over here? Well, if at any time you can keep this number positive, that's better. So I wanted to keep 3 as positive. That's why I moved both of those over there. So now it's in standard form. This one already in standard form, x squared x constant. 4, all I need to do is take this right here and move it to the middle. So when I move something to the other side, it changes sign. So I got 3x squared minus 24x and the 45 is already over there, so it stays the same sign. Sorry, my allergies are messing with me today. Oh, wow. Equals 0. I guess my fingers can't work today. So that's in standard form. This one is in standard form, but notice there's only 2 terms. This one is not in standard form. I need to move them both to the same side. Now, if I were to move this over here, that changes that to a negative 7x squared. And remember I said if at any time possible, you could keep the x squared term positive, it's better to. So instead, we're going to move this over here. And we're going to get 7x squared minus 21x equals 0. Right? Standard form. This one is not anywhere near standard form. So I'd have to move the 49 over. And then I would have to distribute the x plus 2 times x plus 2. So I'd get, this one's a pain. Probably should use my, I'll use this instead. X plus 2, x plus 2, minus 49. I would then distribute x plus 2 times x plus 2. And going by memory, that'd be what? X squared, 2x. So it'd be x squared x times x times 2 is 2x. And this is just called distributing. 2 times x, 2x. And then 2 times 2 is 4. Combine like terms, and you'd get x squared plus 4x minus 45 equals 0. Now you may be asking yourself, why do you keep trying to get this equal to 0? Let's see. Oh, we could do this one too. Again, I want to keep the 24 positive, so I want to move the x over here, make it negative x. Move the 3 over, make it negative 3. So I'd get 0 over here now. 0 equals 24x squared minus x minus 3. So you may be wanting to know, why do you keep making this 0? And the reason why is we're going to use a new property. And the property is the zero product property. The zero product property says if you're multiplying 2, 3, 4, any set of numbers, and the product is 0, see how this says 0? Then that means that either A was 0, B was 0, or C was 0. So in other words, if I could take something and factor it, so I have x as a factor, and I have x plus 2 as a factor, and notice that those are being multiplied, that means that either x is 0 or x plus 2 is 0. So then I could find the x-intercepts. The x-intercepts are 0 and then negative 2. So that's why 0 is so important. So like on this one, and we're going to use factoring. We're trying to make this square into 2 terms. So when I look at this, I notice that A is 1, and I have 1, 2, 3 terms. So where your brain should be going is to factor x. You're looking for 2 numbers that multiply to negative 24, but add to negative 2. Now we went through that last week how to factor, but those 2 special numbers, doing it in my head real fast, would be negative 6 and 4. So remember, we learned this last week. I put x minus 6, x minus 4. Now the difference is I have equals 0. Okay. Now what that means is I'm trying to find the solutions. I'm trying to do what's called solve. So what do I do? Well, in order to multiply and get 0, because you got x minus 6, and you have that times x minus 4, then here's what that means. That means by the zero product property that either x minus 6 equals 0 or x minus 4 equals 0. And those become very easy to solve because what number minus 6 is 0? That'd be 6. What number minus 4 is 0? That'd be 4. So I just found that the 2 possible values that make this 0 is 6 and 4. Checking my work, 6 squared. If I plug in 6, I'd get 36 here. If I plug in 6 into 2x, I'd get minus 12. And then I got minus 24. And notice that 36 minus 12 minus 24 is 0. If I put 4 in, I get the same thing. 4 squared is 16. If I put 4 in for x, I get negative 2 times 4. That's negative 8. And then I have my minus 24. You combine all those together. 16 minus 8 is 8. And then 8 minus 24 is not 0. Uh-oh. That's not good. Minus 2 times 4 is -8. 4 times 4 is 16. Huh. I'm going to go type it in by graphing. So my solution should be -4 and 6, which I got. Oh. Oh. That's supposed to be a +4. Ah. So that's x minus 6. That's x plus 4. So when I bring it down, that should be x plus 4. So what number plus 4 is 0? That'd be -4. Good thing I checked my work. So now that's going to change this. -4 squared is still 16. But -2 times -4, now that's 8. That's +8. Because negative times a negative is positive. So now that works because 16 plus 8 is 24. Take away 24 is 0. So this is why you always check your work. You can either plug back in, like I just did, or I got 6 and -4. That's what it should be on here. -4 and 6. Number 2. Number 2 looks a little different. It's already in standard form. We did that a few minutes ago. The thing that makes this different is this 3. Remember last week, I taught you there was just one little extra step. And I'll do it over here because I need all the space I could get. The extra step was you take 3 times -4, that's -12. Oh, I know what I'm doing. I'll just type it in like that, -12. And then you pull down this number, which is -1. And you want two numbers that multiply to -12 but add to -1. That would be -4 and 3. -4 times 3 is -12. -4 plus 3 is -1. I then write this as x minus 4, x plus 3. The only difference is, remember, you have to take this 3 and divide them both by 3. And then if it reduces, like here, 3 over 3 makes 1. So this becomes just x plus 1. But over here, 4/3 doesn't reduce. So I need to take that 3 and slide it to the front. So I get 3x minus 4. Now we're trying to solve this. We're trying to find the x-intercepts. This one's easy. What number plus, well, we need to use the zero product property that says if you're taking 3x minus 4 times x plus 1 and you're getting 0, that means either 3x minus 4 equals 0 or x plus 1 equals 0. Now x plus 1 equals 0 is very easy to solve. It's the opposite of 1. That's how you get 0. That'd be x equals -1. This one, on the other hand, takes a little more work. 3 times what number minus 4 is 0? Probably the easiest way, like I could look at this and go positive 4/3 is the answer because I've been doing this a lot. But the way you would go about this is you solve for x. So you would add 4 to both sides. Those go away. You get 3x equals 4. And then you divide by 3. So that's why you take algebra 1 before algebra 2. Because in algebra 1, you've already learned how to do this. So you get x is 4/3 or x is -1. So as my final answer, I'd say the solutions are x equals 4/3 or x equals -1. Now let's check our work. I could plug 4/3 in, but fractions and squaring and stuff. I'm just going to type this into Desmos. 3x squared minus x minus 4. Look at my solutions. 1.414. That is not the same thing I got. That is not the same thing I got. I noticed I forgot the x. That changes things. Oh, 3x squared minus 2x. Oh, there was no 2. I'm just changing the whole problem. There we go. -1. Did I get -1? Yes, I did. Did I get 4/3? 1 1/3 is the same thing as 4/3. If you type in the calculator 4 divided by 3, you get 1.33333. So I feel confident about my answer and my solutions. Okay. Number 3, I think you can handle number 3 yourself. 4, you can handle yourself. We'll do number 5. Number 5, it's already in standard form. You might be tempted to start with this. However, you can only do that when there's 3 terms. We only have 2, so you cannot do that. So when I see 2 terms, you should be thinking difference of 2 squares. That's not a minus, so that's not going to work. Or GCF. And looking at that, I go, you know what? There is a GCF. The GCF, if I think about 4x squared and 6x, the biggest thing that goes into both of those is 2x. What's left over? You take 4x squared divided by 2x, you get 2x. Because 2x times 2x is 4x squared. Bring down my operator of 6. 2x times what is 6x? That'd be 3. If you take 6x divided by 2x, you get 3. I personally think these are easier because now we have the zero product property that says in order to get 0, either 2x equals 0 or 2x plus 3 is 0. Now solving this is easy because 2 times what is 0? That'd be 0. Or you could divide both sides by 2. And 0 over anything is still 0. Those cancel. And you get x is 0. So I have one x-intercept is 0, one solution is 0. For here, I could do this one in my head. That'd be -3/2. But just to show the work, I'd -3 from both sides. Those go away. I get 2x equals -3. divide by 2. And I get x is -3/2, which is -1.5. So my two solutions are x equals 0 or x equals -3/2. Those are my solutions. Let's go check my work. 4x squared plus 6x equals 0. Notice I have 0 as a solution, and I have -1.5 as a solution. That is what I just put down. So I know without a doubt I'm correct. So while you're working on these, let me zoom out a little bit. The top 8 solved by factoring. You should have work. Okay, I should see your factoring. Problems like number 8 aren't done yet. 9, 10, 11, 12, 13, 14. You're going to solve those by graphing. If you could put in a screenshot from Desmos, that's great. But I'm not really looking for work for 9 through 14. I'm just looking for solutions. But 1 through 8, I'm looking for work. So we learned 2 different things today: solved by factoring, solved by graphing. I hope that's enough for you to learn. I'm going to go ahead and sign off of here, and I'll see you the next class period.